Hi everyone, good morning. My name is Bismillah Kani. I'm a senior AI scientist. Today I'll be taking a session on the topic end-to-end MLOps using SageMaker. Uh, so the topics that we will cover in today's webinar is as below. So first we'll start with understanding what is a machine learning project life cycle, and then we will see how we can apply the concept of continuous delivery for machine learning projects. And we will see look into like what are the challenges in implementing end-to-end MLOps in a data science team, and what are the best practices and reference MLOps architectures for different types of data science teams. And finally, we'll see a hands-on demo on implementing an MLOps end-to-end pipeline using SageMaker. And finally, we'll conclude with the summary. So let's get started. A typical machine learning life cycle looks like what is shown here in this flow chart. So typically what you will start off with a machine learning project is that you have a business problem that you want to solve, and then you do a little bit of research and see if a machine learning solution is a right fit for your business problem. And once you determine that a machine learning is a good fit for your business problem, then you frame the business problem into a machine learning problem, and then you kick off your machine learning project. So once the project is kicked off, then you assemble a team of data scientists, ML engineers, and data engineers, and so on and so forth. And then we start off with like three major activities. One is on preparing the data part, and then the model building and training part, and finally the most important is the model deployment and monitoring part. So first we will start with the data part. So typically there will be different roles in your machine learning projects, like as I mentioned, data engineers, data scientists, and ML engineers. But it could also be that there is just like one man army, like who's doing everything from end to end. So you could have a data scientist who starts working on this machine learning solution and start collecting data from different sources and integrate all the different kinds of data source. So the source of data could be like tens and hundreds of different sources. For example, if you are developing a machine learning solution for an IoT applications, there could be like hundreds of sensors which are like sending data. So it could be a batch data, or it could be real-time streaming data. So all these things, it has to be taken care. You have to do a data integration, and the raw data will not be directly usable to your machine learning modeling. So you have to do some sort of cleaning, analyzing the data, and prepare your data in such a way that it could be used for your model building and training, right? So once you have the data in the right format, then the data scientist starts with the model building and training, and then he do a lot of feature engineering to determine what is the most optimum set of features for the chosen model. Then the data scientists come with a baseline model, and then iteratively start improving this baseline model by doing hyperparameter fine tuning and etc. Right? So then once you achieved a good model, then you check whether your model meets the business goal. If not, then it goes into the iterative cycle of go and collect more data to in order to improve your data performance, or you might do some more future engineering or future augmentation in order to achieve the business goal. Now after a several iterative cycle of model building and training and tuning, finally you will meet your business goal. So once you meet the business goal, then there is an approval process. Then it is approved for model deployment and model consumption by the end users. So once the model is deployed, the story doesn't end there. The most critical part and sometimes the most missed out part in the entire machine learning lifecycle is like the monitoring and debugging. So this is where the most failures happens, that your model might be performing good, it might meet your business goal, but once it goes into productions, you will end up seeing a lot of surprises from your customers in terms of customer complaints that your model is not performing well on a certain data, right? And it ends up not so good to have such kind of customer complaints. So it's very critical to have this monitoring and debugging piece into your machine learning full stack. Okay. Now you can see that if you actually compare this with the typical software development life cycle, they look similar, but they are quite different at the same time. So a machine learning project is quite different from a software development project. And you can see that in a software development a project, we manage the entire life cycle from requirements analysis to development to testing and to production. So there are like a lot of automations, right? So we have this code build pipelines, Jenkins pipelines, and making it more automated and more streamlined. But in most of the machine learning projects, all these processes are handled manually. And these manual workflows become bottlenecks, impacting productivity, performance, and cost. And that is why we need a good MLOps architecture. So that is the motivation behind why we need MLOps. Right. So moving forward, uh, so today we are actually looking into using or leveraging the AWS services, mainly the AWS SageMaker, and how we can leverage AWS SageMaker services to actually create a, an MLOps framework, right? So now we understood what is a machine learning lifecycle. Now, how we can fit this machine learning lifecycle into a AWS well-architected framework. So, a AWS well-architected framework has five main pillars that determines whether your architectures are following the best practices in these five categories. And those five categories are performance efficiencies, reliability, operational excellence, security, and cost optimization. So since it is an iterative process, these six steps, whatever determining the business goal, ML problem framing, data processing, development, deployment, and monitoring, all these things has to be designed in such a way that it fits into the well-architected framework of what AWS has defined. Okay. Now, so what AWS recommends or follows certain principles for developing a continuous delivery for machine learning. So there is something called CD4ML. So they have come up with this framework or operating model for creating a continuous delivery for your machine learning projects. So it has like six main things which are kind of aligned to the machine learning life cycles, from model building to monitoring and observability. Now, what is the continuous delivery will achieve is that it is an approach to bring automation, quality, and discipline in order to have a reliable and repeatable process for machine learning. So as I mentioned, there are like six main building blocks is in this continuous delivery for machine learning. So the first one is the model building. So in model building, it is very critical to have an automated and reproducible machine learning pipeline so that the data scientists can collaborate uh, on the same code base rather than having a carbon copy of the same code by different data scientists, right? So typically, when there are like machine learning or data science teams where there will be like more than one data scientist working in the same project. So what happens is that they have their own copy of code in their own local computers, right? And then they start working on it, and everybody is trying to achieve a better performance of the model. But it prohibits the collaboration between the data scientist, and it impacts the productivity and also the reproducibility. So when you have an automated and reproducible machine learning pipeline, then what you can do is you can test the same model or the same code into a different environment with a different data sets, and this enables flexibility, trackability, and reproducibility. So as you can see, this entire framework is being divided horizontally across the code, the model, and the data. And then this, when you have like multiple data scientists, they can share the same code across the entire team, and they can also like use multiple data sets, and they can test the same code with the different improvements they made, and finally they can compare different models and select the best model for further evaluation and experimentation. Okay, now in the next step, what we have is evaluation and experimentation. As we all know that machine learning is a very empirical research process. It demands lot and lot of experiments. There is no one solution fit all concept in machine learning, right? So we need to conduct and design multiple experiments in parallel to achieve the most optimum model for deployment. So since we have like a lot of experiments in parallel by different data scientists, so you will end up with hundreds of experiments, and it will be very cumbersome to actually select which is the best model. So it is a good practice to track all these experiments automatically and version the codes on for every experiment, what changes you made, and so that you can track the changes of the code for different experiments. And then also, not only the code versions, you should also track the dataset versions. So sometimes you will improve the data because you cannot achieve the best model just by trying different architectures or doing hyperparameter tuning. Most of the time, the best model is achieved by cleaning the data and improving your data quality, improving your label quality, right? So you can use an active learning pipelines in order to determine which data is having certain issues, and how can you improve the model by adding these kind of data into your training. So you will end up with multiple data set persons, and of course you will also have a different hyperparameters that you used. So we need a platform to track all these experiments, visualize them, and compare the results of these different runs, right? And then in order to choose the final model. So and once, let's say, after your rigorous experimentation, you find the final model for deployment, then you go for the model deployment. So in model deployment, then you have like two tracks. Either you deploy a model in edge, or you might deploy a model in cloud. So depending on it, you have to design your model deployment architectures accordingly. Okay. So once you deploy it, then you have your productionized model. Now you have a productionized model to be deployed into your to your customers, but you cannot directly do it before testing, right? So you need to go have a proper testing paradigm so that it meets all the business requirements, and then only you will have a final approval criteria, which is then approved and then applied to the which is then deployed to the production. Okay, so I'm sorry.
So, Bismillah, there is a question: how is MLOps different than DevOps?
Yeah, so MLOps concept is actually inspired from DevOps. So DevOps is mainly applicable for software development lifecycle, and MLOps is applicable for machine learning development lifecycle. And I have worked in like multiple companies in which deals with this AI and data science, and there is like a huge software development team. And whenever I say MLOps, they also have the same question, like what is MLOps? So I would say like most of them have never heard about the concept of MLOps, although they are very familiar with DevOps. So MLOps, the formal definition of MLOps is as follows, right? So MLOps is a set of operational practices to automate and standardize machine learning projects. Okay, and what are the different operations or they're involved in machine learning projects? You have this model building, model training, model deployment, right, and model monitoring, management, and governance. So these are like a standard uh, operational practices in order to uh, automate these processes. So it's a similar to DevOps for software development, MLOps is for machine learning development. And the key advantages of using MLOps is that it boosts data science productivity, right? And it maintains high model accuracy and quality, and also it enhances the security and compliance, and it enables flexibility, reproducibility, and trackability. Because what happens is that most of the machine learning projects fails, and there is a Gartner report saying that only 53% of the machine learning projects POC makes it to production. And one main reason is that they do not follow these standard operational practices, right? So we will see that what is the challenges we have in this MLOps, and how can we implement a proper MLOps architecture. Okay. Okay. So now we know what is the machine learning life cycle, what are the different steps in machine learning life cycle, right? And then we looked upon what is a how we can apply continuous delivery for machine learning as we apply continuous delivery for software development, right? So the answer to how we can do continuous delivery for machine learning project is basically the MLOps, as DevOps is for software development. But you cannot take a DevOps model and then directly implement for a machine learning project. It does not fit. They look, some of the concepts are similar, but they are very contrastingly dissimilar. And that is why we need a technical leader or a person, right, who understands both worlds of this DevOps and also the machine learning, right? A software DevOps engineer cannot fit into a machine learning project, and just a pure data scientist cannot implement an MLOps. We need a person who understands the 360 degree of both the model building and training and also this operational practices. And AWS or in general, they recommend that in order to build an MLOps foundation in an enterprise, right, which covers these operations, peoples, and technology, it could be very challenging to make it work for you. So they say recommend that to implement MLOps, you take it in phases, and they define like 4 phases as shown in this picture. One is the initial phase, then the repeatable, and then the reliable and the scalable. Now, what is initial phase, right? So in the initial phase, what you do is you have a bunch of data scientists and they are working on a machine learning problem, and they are trying to find a solution to your business problem using a machine learning approach. Now, what in initial phase should be your objective is that you just establish an experimentation environment for your data scientists. What I mean by that is that your data scientists should be able to experiment and collaborate based on notebooks, right? So they basically majorly work on Jupyter notebooks. So they should able to collaborate. Multiple data scientists should be able to collaborate, and then they have to do this experimentation to bring up the best performing model. Now, but there is a challenge here because every data scientist might be there is no automation. There is this in this initial phases, it is completely manual. Everything is manual. Okay. And then what you do, you move from initial to a repeatable phase where you create automatic workflows, right, for your pre-processing data, your building and training models. And this automation is achieved by something called as machine learning pipelines. So today we will see what is a SageMaker pipeline and how you can create machine learning pipelines using SageMaker. Now, one is automation using machine learning pipeline. The second would be is the what this machine learning pipeline generates. This machine learning pipeline generates finally a model, right? A model to be deployed and consumed by your customers. Now, this model has to be stored and versioned properly. Um, so for doing storing and versioning of these models, we use something called as a model registry. So this model registry will have all the models that comes out of your machine learning pipeline, and you have a trackability of this model. So then like you can compare all the models in this model registry and then approve only the model that meets the business criteria. Okay. So then you go from repeatable to reliable phase. In this, what you do is you have like different stagings, right? So in software development, we have this development phase, then you have this staging phase, and then you have this production stage, right? So that's why that practices we are trying to introduce to machine learning projects as well. So you will have like multiple stages with multi-account deployment. It depends like whether you want a multi-account or you can even do it with the same account also. Then we go for a fully matured MLOps model. With for that we will use more of a templatized solution and productionize multiple ML projects. So you might be working in an organizations where there is like tens and hundreds of machine learning projects, and there are like a few hundred data scientists working on it, right? So you can then templatize all these good practices of machine learning automation using ML pipelines, model registries, and your code pipelines. Everything can be templatized so that all the projects will follow the same template. So that then you achieve a fully matured MLOps model. Okay. So this is a typically how an ML machine learning project is worked upon at an initial phase, right? So now you can see this is in the context of AWS, but you can just also extend this to any other um, um, environment, not just AWS. So this is generic enough to be applicable to any environment. So what you have is like you have data scientists. So then they they start working on the machine learning problem using Jupyter notebooks, right? Typically, and then they have the model building and training going on in this Jupyter notebooks, but they will pulling the data from different sources, and those data can be coming mostly from S3, but sometimes they can also come from other data analytics platforms like Redshift, AMR, or relational database, or a NoSQL database like DynamoDB. Okay. So finally, this data scientists, they work and they build a model, and then they push this model into S3. So normally, let's say if it is a PyTorch model, you have a .pt file or .pth file. Or if it is a machine learning model, you have a like a pickle file in a model, right? So then you put it into S3. So what happens next? That's it. What Gartner report predicts that 53% of this POC doesn't make into production. It just ends up into your Jupyter notebooks and doesn't progress much after that. Now, let's say that, okay, so now you have trained your models, right? You have your final model to be deployed. Then a better way to make it to production is you take this model and create Amazon SageMaker endpoint, right? So you expose your machine learning model through SageMaker endpoint. Now this SageMaker endpoint can then be exposed to the customer through API gateway, and then the Lambda acts as a proxy between your customer's API request and to your endpoint. Okay, this is how even I started to create my machine learning solution of when we want to deploy our machine learning projects. So we started off with some problems. We collected data, we trained different models and find the model, and then uh, the main challenge was how I can deploy this model. So after like going through a lot of learnings, we figured out how to deploy as a SageMaker endpoint, and we also expose this as a API gateway. So this is how probably like we in CellStrat also we started like this, right? So we can see many of our codes will look similar to this. But the thing is that it has certain problems that this is okay for okay for a single person project, but when you have a multiple person project, then what happens is your training code is kind of stuck into the one person's notebooks, and if you want to share it, you just have to download this copy and send it to the other person, and then he imports and he runs it. Okay, so it kind of stucks into your local environment. And then if you want to make any changes or if you want to update this model, then you have to do a lot of manual updation. And then another thing is you don't configure your endpoint for auto scaling, right? Because you don't know what kind of traffic you might expect once you productionize your model, right? So it might be that your model is reached a lot of attraction, right? And a lot of users want to use your model, but then it is just like one single instances you have deployed. Now it cannot cater to the huge demand that has suddenly surged, right? So you, in order to meet that, you need to have an auto scaling configuration on your SageMaker endpoint. And finally, it also that there is no feedback loop designed into this project. So you will not get any feedback other than customer complaints when the model doesn't perform good. So what could be a good MLOps architecture, in order to solve all these challenges in MLOps? So you can see in this region, it is mostly what we have seen in the previous slide. We have a data scientist who is working in notebooks, right? And he has like different data sources. Now, one additional improvement what we made is it is no more a local change. It will be connected to a GitHub repository. So in this case, we are using AWS code commit, but you can also use any other GitHub repositories like GitHub or Bitbucket based on your project requirement. So then you push all your changes to your model codes into the code commit. And you can also spin up easier environments, but we will not go into that now. And finally, once you have a model built and trained, you push a model artifacts into your S3. Now, you can also automate this machine learning using SageMaker pipelines, which is essentially building a machine learning pipeline. So it will have like sequence of steps like pre-processing, training. So then you can just create a new pipeline, commit it. Then the SageMaker will run the entire pipeline starting from pre-processing till model building, training, and evaluation. So we will see this in action today. Okay. Now, how can you make this automated or how can you trigger this, right? We can use Amazon Event Bridge. Um, so this could be triggered either like on a regular interval, let's say like every day or every week, or you can also do a manual trigger, okay, so that it triggers this SageMaker pipeline. Now, once the SageMaker pipeline is finished, it will have a model ready for deployment. Okay, so then that model is pushed into your model registry. This model registry tracks all the models that comes out of your different experimentation. Okay, now you compare different models and you only approve the model which meets the business criteria. So once a model is approved, then we create a SageMaker endpoint. But this time we have configured auto scaling group, okay, so that it can scale up or down. That is basically horizontal scaling based on the traffic surge or down. Okay. And of course, you can expose your endpoint to your customers through API and number. So this is like same as previous. So this is like a very good reference MLOps architecture if you have a small team of 1 to 3 data scientists. Now, if you have like a little,
Bismillah, there was a question on chat.
okay, yeah. AWS code commit can be connected to Event Bridge, right? Whenever there is a new code commit. Yes, yes, correct. That is true. So this event bridge, the source of event could be multiple things. It could be an API call, or it could be a cron based trigger, right? Where like every regular interval, or it could be like anything. Even if you like have an S3 based trigger, if you drop in a new data set into S3, that could also be a trigger in order to kick off this SageMaker pipeline. Yep. So this is the same thing as what we saw there. Okay. But additionally, what we have here is that we have a multi account strategy, which means that so you have a staging account where you deploy it and then do the testing. And once the testing is passed, then you push that model into a production account. Okay. So this looks similar to what we saw before. Most of the components are same, having a code commit or a SageMaker pipeline, model registry, triggers based on event bridge, right? And then you also have a SageMaker model monitor. This is a new thing. Um, and then like once we approve the model, then the code pipeline push that model into a staging account where we create an endpoint. So after the testing, then we approve that, then that code pipeline will deploy the model into the production account. So this here is a tester. So here is actually the end business users. So this is a good practice of having a multi-account strategy so that you don't accidentally make mistakes into your production model.
So Bismillah, this is pretty complex architecture. So an MLOps person has to manage all of these elements, huh?
Yeah. So that is why I said, right? So it depends on a, a person who knows both the worlds, right? Both the worlds of a model building and training, and also this MLOps, or the model deployment. Um, it, those There should be a person like that in a team. Then he can set up this.
Can a DevOps architect graduate to MLOps architect expertise, or it has to be AI/ML expert who learns MLOps?
Yeah, from my experience, DevOps, they do not understand what is this MLOps actually. So
Because you are saying they don't have AI/ML core knowledge.
correct, exactly. So they
Okay.
don't understand what is model building and
But
training.
the question
What,
is, can they upskill themselves into it?
yeah, either that is the one way, like either the DevOps guy has to upskill to have at least a basic knowledge of what is a machine learning project,
Hmm.
or a data scientist whose core skill is on model building and training should also extend his skill set to this kind of MLOps thing.
Okay.
So
Hi, Bismillah, this is Sarang. So, if you see, right, so here the data scientist, once they write the code, that their part is done. The rest of the environment setup can be done by the AWS DevOps guy. So, who knows all these, the components, what are you saying, gateway, lambda, everything. So, whenever there is a performance degradation or data drifting, something, they can set up a trigger that goes to the data scientist, then they can pitch it in the code, right? So, because data scientist upskilling to MLOps, that means understanding this AWS environment is a tedious job.
correct. Yeah. Yeah, I think DevOps guy has to do, but what I feel in my practical experience is making the DevOps guys to understand this is also a challenge. So they do not know how to build a SageMaker pipeline, right?
Okay.
So that also becomes a challenge.
So
So
there is some
data
upskilling
science,
need.
we can only work on Jupyter notebook.
Hmm. So
Okay.
there is upskilling needed both ways, whether you come from DevOps to here or AI to MLOps. So you have to upskill in the missing component quite a bit, I guess.
Yeah, I think what he says is correct. To learn all the components from AWS will be difficult. Probably a data scientist at least should know how to manage the SageMaker pipelines and model registry. But probably this code pipeline, code build, those kind of things, probably DevOps has to handle. Yeah.
And one more thing to add is that see, basically this is one time setup. See, once you have that pipeline ready, I mean, you will know the things where it is, and it's easier the implementation. See, if whenever there is a change, you might make a little change, but ideally it remains standard for most of the times, right?
Correct. Yes. Yeah. Correct. Yeah. We need to have this setup, right, and then it is going to work, kind of going to work for every time. So only thing, this area will be the most dynamic thing. Like the data is going to change. The data scientist is going to run like a lot of experiments. But if you do this all this configuration ready, then it is going to work. You just have to push your changes and push your models to your registry, and that gets kind of deployed after staging. Yeah, correct. Okay, so any other questions? I think it's okay. Yeah, so if not, then we'll move on to the demo part. Okay.
Hey, this is Krishna here. I have one question.
Yeah,
Can you please go back to that slide?
this one.
Yeah, this one. Yeah. So what is this Amazon Event Bridge and API Gateway?
Okay.
And what?
Yeah, so Amazon Event Bridge is basically like a trigger. Like, so it listens, it's more of a event listener. Okay,
Mhm.
and the event could be of anything. So the event could be of an API call, or the event could be like an S3 bucket, a data upload, right? Or the event could be like n number of things out there. Like then
Basically,
what will happen is, yeah.
to add to that, basically in this pipeline, in this particular pipeline, when you have a new model in place, what happens is this event will trigger that code pipeline,
Mm,
so that it can get deployed. So that's what if there is a model change, that's what the event
Mhm.
bridge will do. Okay, so ideally that's the thing.
correct.
That's the job of a event bridge. What it does is, if there is a change in the model, or if there is a new model that gets into that SageMaker model registry, you will
Mhm.
trigger the code pipeline using this event bridge, event listener, and accordingly it will get deployed as in AWS SageMaker's endpoint. Okay.
So,
So
actually, where are you deciding which is the best model in this pipeline? I thought
Yeah,
Event Bridge. It says
no, no,
model
no.
approval.
Yeah, there is a manual approval process here.
So is that not automated?
No,
So
you can
there has to be
automate, but it
programmatically
is
you have to take a decision, right? Out of say some five models, which is the best one. Is
yeah,
Event Bridge going to do that, or it just picks up
no,
the
no,
best model decided by the, I don't know,
no, no.
where is it decided?
Yeah, yeah. So there is a approval process. That approval process could be automated, okay, but it could also be that there is a manual approval process. I will show that in the demo actually.
So we are saying only the final model goes to Event Bridge, is it?
Yes, once you have the status, there is a, see, once you push a model into registry, the
Okay.
default status of this model will be pending approval.
Okay.
Okay. And then you can then manually uh, change the status from pending approval to approved.
Hmm.
Okay. Once it is being approved, then that will trigger the code pipeline. So the event will listen to the approved status. That is
Okay.
basically the event here, and that event bridge will trigger this code pipeline.
Okay.
Right.
What about the Amazon API Gateway on the right side? On the
Okay.
user side,
Yeah, correct. So you have to expose your model to the outside internet, right? S- so it's basically like you, the end users consume your model through REST API request.
okay.
Yes.
Oh,
So
that's
that,
what you're there. Okay.
yes, yes, correct.
Okay. Got it. Yeah.
Yeah. Okay. So now I will come to the most interesting part, which is basically the SageMaker Studio. So you can see my AWS console.
Yes.
yes.
Okay. Yeah. So if you so AWS SageMaker, if for those who are not aware of what is AWS SageMaker, it is an fully managed machine learning services by Amazon. Um, so there are like multiple things in AWS SageMaker, and one is the studio. So what is AWS SageMaker Studio? It's a fully integrated, as is shown in this thing. It's a fully integrated development for machine learning. So it has all the components that is required to manage your complete machine learning projects. Okay. So basically, like you set up a SageMaker Studio, then what you do is you just open the studio, then you will land in this page. Okay. So in this, it has multiple things like a data related things like a data ranker, features, tools, and clusters. All this we will see it in a different time, but today we'll focus on how to create an MLOps project. So for that, what we have to do is we go to deployment, okay, and then we create a projects. So I was telling you in one of the slide, right? We go to a templatized model of MLOps. So this is what will be achieved in this. So you click projects, okay, and then it asks to create project. You say create project. Then what will happen is it has a standard MLOps template for your machine learning project. Okay. So these are like standard templates provided by AWS, but it also is possible that you can create your own customized template. Okay. So today we will see how to use this template, which is model building, training, and deployment. And you can see what is the description. It is basically this template is used to automate the entire model lifecycle from building to deployment, and it also uses a continuous integration and deployment of the ML models using code commit and code pipeline. Okay. So it uses these three things: SageMaker pipelines, code commit, and code pipeline. So you can replace if you don't want to use AWS code commit or code pipeline. Let's say your existing enterprise or company has all their codes in GitHub or Bitbucket, or they don't use code pipeline, they instead use Jenkins pipeline, then you can also do that. So for that, you can use this template. So this template will use third-party Git and not this one. I think this one, Jenkins. You can use third-party Git and also Jenkins. But for simplicity, since we are just starting, we will use this. Maybe in another session, we'll go to those third-party Git and Jenkins. Okay. So select this and select the project template, and then just give a name, right? Say MLOps demo by SageMaker in CellStrat. Okay.
Basically, you're creating a project, is it? You're creating, what is that you're creating here?
Yeah, we are creating an machine learning project, but using a template.
Correct, correct. So basically, you're within the AWS Studio, right?
Correct. So I am within SageMaker Studio, and right, once you open the SageMaker Studio, right? So this is SageMaker Studio. So you have this, and then there is a deployment option. In that you have this project. If you click this project, it will ask you which template you want to use.
What?
I choose this. Yeah.
Right.
Then if you create this project, so what this template will contain is it will have like already the codes and the configuration files and all this boilerplate codes ready for you, right? So it also has a ready-made project which is based on the abalone dataset, which is a simple XGBoost model. Okay, So for understanding the concept of MLOps, we will use this, but you can extend this to any of your machine learning project. Okay, you can just take this and then modify it to your project. Okay, and then you should be good to go. So once you create project, it will take couple of minutes to bring all this together. Um,
So Bismillah, any overlap with or any connection to CDK in AWS? That's a different concept, right? It's not related to MLOps per se. It's just programmatic DevOps.
yes. So CDK is not just for machine learning. CDK is it's a general DevOps. What is called what's called infrastructure as code, right?
But can you manage MLOps with AWS CDK, programmatic DevOps?
Yes, I think we can, right? Yeah. But again, then you should know how to do MLOps. Sorry, you should know CDK, how to write constructs with CDKs, right? That is totally another challenge for data scientists to upskill and to learn all this. Okay. The advantage of this SageMaker studios and projects is that it is much easier for data scientists to cope up with this MLOps. Okay, so you have a existing template. Okay, so all you need to do is go to the SageMaker, create a studio, and then go to projects, and then create a project. It creates all those templates for you, all those things, and then it also creates this machine learning pipelines, right? And then it creates the model registry where your models are stored and tracked. And then you can also do this approval, right? All these components will be there. Most of the components will be shown in this will be there. So this machine learning pipelines, this model registries will already be there. Okay, and also this code pipeline and code build will already be there. Code commit, sorry, will already be there. So uh, so then it will be much more easier for the data scientists to start their work, right? So it will be like several steps ahead before he actually goes and learns all the CDKs and then construct all these things. This every entire thing can be done in AWS CDK, right, through constructs. But it will be too much for a data scientist to learn and do, right?
Right, right.
Yeah. So now it's done. Okay, so it is successfully created this project, and you can see it is in this project we have repositories, we have pipelines, we can do number of experiments. Then this is where the model registry, the model groups will be stored, and once you approve it, it creates a SageMaker endpoint. Okay, we will all see this how we can do it. So now what it has done is it has a two code folders actually. So one is for building, another is for deploying. So what we will do as a first step, you clone this repository. Okay, so you clone it. And you clone this as well. Okay. So what happens is the code is there in the code commit. So when we created this project, there was a code there is in the code commit for your model building as well as your model deployment. Okay. And we just cloned it to our local so that we can look into our code and we can also make changes and push that changes back to code commit. Okay. So now what happens is a machine learning pipeline has already been triggered. Okay, in this you can see. So there was so if you see, the machine learning pipeline has already been triggered and it is executing it. And if you see the graph, what is this machine learning pipeline has? So it has a pre-processing step, it has a training, it has an evaluation, and then it checks whether that the model meets certain criteria, and then only it registers the model into your model registry. Okay. Now, how this machine learning pipeline will look, or how it was created using code, right? It was already created for us, but we will go and see how this was actually created into the code, right? So now, meanwhile, this will take like 2-3 minutes to execute this entire pipeline. We will see the code. So if you go into the our local copy of our code, right? Just 1 second. Yeah, it has two folders. One is for the uh, um, uh, one is for the build, another is for the deployment. Just 1 second. Yeah. So now we will see the build. So in this, you can see that it already come up with the codes required for this running this pipeline. Now, if you go into the pipelines, okay, then this is a very toy example which is using a baloney data set. Now, if you go into that, then this is where the pipeline was built using SageMaker SDK. This is all Python code. Okay. So if you are familiar with SageMaker SDK, then it should look familiar for you. So now it has 4 major steps. Okay. So we will see that. First, it is doing, see, this is the first step. That is, it is doing a processing, data processing step. So it is using the SageMaker SDK sklearn processor. Okay. And this is your training data, validation data, and test data. And it runs the data processing. And once you have the data processing, it does the training. Okay. It uses the XGBoost model. Okay. And then using the SageMaker estimator, it trains the XGBoost model on this processed abalone data. Okay. And uh, then you have the model. Then what we do is the third step is evaluating your model based on using your test data, for example. Okay. And then finally, it registers the model only if it passes a precondition. Okay. So that condition is also configurable by the data scientist. Okay. So now you see we have this 4 step. Now this is where the pipeline is created by combining all these 4 steps into like one pipeline. So you can see the steps. What are the steps this pipeline has? It has a process step, it has a training step, it has an evaluation step, and it is a conditional approval step to push a model to your model registry. This is what is being executing here. Okay. If you see this in action, you can see now the process step is completed. Now the SageMaker is training the abalone model on our processed data, and once it is completed, it will go through the evaluation and checks whether it meets the condition. If it is true, then it registers the model. Okay. So we have to probably wait for some more time to complete this. Now you can also see this, how this is what is happening in the code pipeline. So code pipeline is what is triggering this, right? Code pipeline is what will trigger this thing. Now you can see, just forget about deployment because this is still not approved. That's why it says fail. But what is happening now is the model build pipeline. So you can see that if the code is committed from code commit, then it built and it is now in progress. Right? Once this is completed, this entire thing is completed, this also will be moved to in progress to completed or succeeded. So you can see that how all of the components are working together. So you can also click one of these component in this pipeline, and you can see the input outputs. You can see certain logs here, what has happened, all those things.
So those who are doing AWS certification, by default, they will not have expertise in the SageMaker MLOps. Or is in AWS certification, there is an extension program for SageMaker. Bismillah.
It's a question to me, Vivek.
Yeah. So I'm asking a question. Do AWS certified architects can do this, or they need extension training in SageMaker MLOps?
Yeah, they need extended training in SageMaker. They know the basics of SageMaker, but probably they are not fully aware of the complete capabilities of SageMaker. For that, you need to have a machine learning specialty certificate.
Okay.
Yep. So this will take some time.
So which certification have you done, Bismillah? You are certified architect, or you have done extension trainings as well?
Yeah, I am solution architect certified. I'm preparing for a machine learning specialty, but I'm not getting time now.
Okay.
Yeah.
All right.
Um,
So some of us are familiar with CellStrat Hub AI deployment architecture. So, but that doesn't come close to the complete MLOps ecosystem, right, Bismillah? So that's nowhere close. That just a
yeah,
API deployment scheme.
yeah, correct. Actually, our CellStrat Hub will automate or many of the things. I mean, most critical component, like creating this lambda and exposing as an API gateway, right? So this.
Hmm.
So let's say our data scientists have a model, right? But they don't know how to deploy this model into production.
Hmm.
So they have to learn all this Lambda, API gateway, and creating Docker containers and all those things, which also a little challenging for data scientists. So
Hmm.
if Hub will make that very easy, just with like one line command, they can take the model from this stage to this stage, and then the users can use it. Yeah.
So Bismillah, you are almost propagating or promoting CellStrat Hub here. You are saying that is much easier than SageMaker pipeline, huh?
Yes, definitely. Yes.
Oh, glad to hear that.
Yeah, it is definitely much easier because as someone was mentioning, right, it like a data scientist will not know how to create this part, right?
Mm-hmm. So in CellStrat Hub, we have abstracted out the cloud complexity of AI deployment.
Correct.
It will not support CI/CD or model versioning and other things of this, but the basic AI deployment has been simplified to or extremely dumbified. So a regular ML developer can easily launch AI models. So I'm
Correct.
glad to hear that coming from CellStrat angle.
Yeah. Yeah, I think now it's completed. So now it is executed. It took like 10 minutes. And if you just check the evaluation step, mm, uh, not in the evaluation, actually in the train, you can see that our RMSE was 2.2, which was good enough for a deployment, and that is why the condition passed here, and then it was registered to a model. Okay, so now what you got to do is, if you go to the model groups, right? So there is a model registered in this model group, right? Because it met the condition. Now, if you click this, so there is also a version control here, right? So you can also like it's just since it's the first version, it shows 1. So now you see the approval status is pending, right? You see here. So this it will not go to the next step unless this is approved. Okay. So now in this particular project template, we have made a manual approval process, but this could also be automated. So now what will happen is that let's say there will be a senior data scientist. Okay, so he goes and checks that everything is correct. Then he will go and approve this manually. Then he will say from pending to approved. Then it will go to the staging. Okay, then we can add comments and then it updates the status. Okay, successfully updated version 1 from pending to approved. Now, once it is approved, the model endpoint will start in a minute or two. Okay. Now, if you go to your SageMaker endpoints, now you can see there was no endpoint before, right? So in a minute, you can see that a SageMaker endpoint will be creating. Okay. I think we can also see that the model building was completed. Now what happened is now we have initiated the model deployment pipeline. So as you can see, since we approved it manually from pending to approval, it started the deployment pipeline. And then it is deploying the endpoint in the staging stage. It is in progress. Hopefully here we should see that an endpoint is being created, right? So this is a staging endpoint. So this will take like a couple of minutes to create this endpoint. Now, once this endpoint is created, then you can intimate your staging team, your testers, to test this endpoint and see everything, every unit test is passed using this endpoint. So, so if you go and see in your endpoints, right, you can see that one endpoint is being created. Now, let's say after a minute or two, the endpoint is created, right? So what you can do is you can pass an input payload here, and then you can test your endpoint in here itself. Okay, and then you could also do a lot more things here, right? One of the critical part of in MLOps is your monitoring and debugging, right? You can monitor your data drift, you can monitor your model drift, you can also add explainability to your model, right? Bias on all extra things. So all this monitoring schedule, everything can be configured, but probably for today we will keep it simple. Maybe in another session we'll go all this details later, right? Yeah. I think, yeah. So now you can see the endpoint is created. So now it is ready to use. Okay. Yeah, refresh here. Yeah. Now you can see the staging endpoint is in service. Okay. So now the team will be testing this endpoint. Okay. Now you have to push this into production, right? So now what we have to do is, let's say the testers tested, and then he says that every test has been passed. So now it is okay to deploy it into production. Then you go to the let this completes. Then it will ask for approve for the deployment. Okay, so once it is approved, it will then create a production endpoint. Okay, this see now this is all done by like one single person with like one single account. But it might be that you do a much more granular control. A data scientist cannot come here and approve this, right? There will be another person uh, having a different role, right? Who will actually review the staging and the models, and then only if he has the authority to approve to the production, then that is where that person will review it and approve it. Now, but here we are just simulating that environment, and we are doing everything by one single person with one single account. But normally you can also do with multiple roles with restricted permissions and also with multiple accounts, so that you don't kind of accidentally affect your production environment. So now let's say it is approved. Now the admin, whoever is there, he'll say like approved for a production, right? Then he approves. Then the endpoint will then be deployed into your production environment. Okay. So now in a minute or two, you can see there will be another endpoint created for production environment, production, right? So you can, if I can refresh this, you can see once since I approved in my code pipeline, this endpoint is now pushed into the production. Now it started creating. So in a minute or two, you will see that this is also in service. See here. Yeah. So yeah, that is pretty much I want to show. Let me know any questions or comments.
Yeah, Bismillah, this is good demo. So just one question is that if you wanted to do, means you used only the template, right? Okay, but if you want to change the code, right, then how will take, means,
Yeah,
how
you,
to, yeah.
you can do customization like it's a good practice that what to start with some template, and then you can customize it on the go, right? So in this case, we are just using some toy example of abalone dataset, and all these pipelines, as I explained here, it was configured here, right? So you can go and then change all these codes based on your project.
Okay.
Yeah.
And also commit and things, it will automatically take care of it, or I need to do it that
No, once you make changes, right? Let's say you customize this, then you push that change to your code commit, then that will automatically trigger the pipeline.
okay. So the pushing code and things, is it some buttons and things are there, or means
Yes,
commit?
so it's like we have this GitHub things, right? So for
Okay.
example, if I make some changes, the changes will come here. Okay.
Okay.
Then you commit it with some command and then push that changes into your code, like push these changes. Okay. Push committed changes. That committed changes will be pushed into your code commit, and that code commit will trigger this code pipeline.
Okay. So in this case, I don't have to worry about IAM role and anything, right? It will be automatically take care of it, right?
Sorry.
IAM role and things,
Yes,
nothing is.
that you have to take care. Yeah, you should have sufficient permissions. So you should have permission for code commit, code pipeline, SageMaker, all the sufficient permissions. It has to be configured.
No, no, I need to configure it beforehand, or is it already taken care of it? That's what I meant.
No, you have to configure it here. Like when we are creating this, domain, right?
Uh-huh.
So when we created this domain,
Uh-huh.
so there will be a user you create, and that is actually bundled with the IAM role.
Oh, okay.
Yeah, that one I have not shown here, but yeah, I don't know if I can show it here. So we have created one role, and that role is kind of yeah, right. Yeah,
Okay, this is a pre-step. Okay, understand.
yeah, it's a pre-step. Yeah, so how do I show that? Yeah, so it's a pre-step. Yes, correct. Yeah.
So a pretty good demo, Bismillah. One broad question. So you work on CellStrat Hub also.
Yes, Vivek, you are breaking. Hello. Hello.
Yeah, Bismillah, can you hear us?
Yes, now I can hear you.
So in what circumstances would you recommend CS Hub or SageMaker?
Yes. So for a single person, let's say just like a data scientist, okay, who want to deploy a model um, to use, right? So I would highly recommend CS Hub. So just start with CS Hub, right? And so you can take your model to production with like very few steps, and much more easier and faster. And then once your requirements grows, right, when you just grow from one data scientist to, let's say, a small team of 3 4 data scientists working on a medium to machine learning project, then you want to actually monitor the different versions of models, right? Then you go for this kind of MLOps setup. But for a data scientist who urges, who wants to actually take his model to put it into production, I would say, yeah, CS Hub is the best place. Yeah.
Okay, that's great. So the problem with this whole CS SageMaker is you do need this level of expertise, right? So a plain data scientist can't do this. So they have to have somebody AWS certified or something like that to be able to do this SageMaker MLOps, right?
Exactly. Yes.
So that creates a talent requirement. At least one AWS certified person would be required. Nice. Any other question, audience? So this also gives me talking point when I talk to enterprise customers, when they ask me to compare my company's product, CellStrat Hub, with SageMaker and others. So it does.
In the architecture, we saw the event bridge details. How the event bridge are configured and how does the uh, event bridge basically receives the notifications details and so on and so forth. Is there a way that we can have a look at those configurations?
Yeah, I think that is kind of taken care for you. If you actually go it when you created this project template, right? It also uses a cloud formation template to create all the necessary services required for this end-to-end MLOps project. Um, so that would have been already taken care for you. So yeah, I'm not sure I can see that. Let me see if this particular project uses event bridge, but I'm not sure. I'm not gone into. As you can see, this is one. Okay, this is just the endpoint. I need to look into the details. Probably then I will share it across later. Yeah, or probably that this particular project didn't have an event bridge, but it should have, because that's how, once you approve it, then that basically like triggers the code pipeline. Okay. Um, Maybe we can have a look at the bridge. Yeah, I will look into it and probably I will
No problem.
details later. But yeah,
Sure.
it should probably have created that event bridge already for us, but I'm not
I-
able to see that here.
Is the event bridge is nothing but visual representation of or visually managing things in Lambda?
No, no, no. So event bridge is basically an event listener, right? So when there is an event happens and that event will actually trigger the next action in that thing. So there will be a source and then there will be a target, right? So there will be a bridge between the source and the target. So here the target is to run this code pipeline, and then the source is basically the event of the source is basically this model registry, right? And once like I push that status from pending to approved, that is basically an event, and that event will trigger this code pipeline. Able to follow me?
Yeah, thanks.
Yeah.
Okay, any other questions, folks? So, Bismillah, are you working on SageMaker with your employer, or this is not something you do normally at work?
Yeah, I do every day basis. I work on SageMaker. Yes.
Oh, you do? Okay, okay, excellent. But you are saying for small data science teams or individual startup maybe, or individual data science scientists, CellStrat Hub is more recommended. But for larger teams like your employer, which has like more extensive models in AWS, maybe SageMaker may be needed.
Yes, yes. So SageMaker is a managed MLOps service. Okay, but there are also like a lot of alternative open source things. Okay, but I would recommend to actually go with this managed service, because if you go for open source, there is like a lot more overhead on you, right?
Hmm.
To manage everything. Everything is self-managed, right?
Like Heroku and others, right?
Yes, yeah, correct. Yeah. So this one like kind of makes the life a little easier
Hmm.
to set up MLOps.
So, Bismillah, are you saying something like CellStrat Hub is not going to cut it for your employer's work?
Uh, yeah, it depends on the type of enterprise or organization.
Right.
In my type of organization, I don't know if like there might be a lot of other
Hmm.
security approvals and
Right,
all,
right.
right? So it has to
Yes.
go through a lot of screening process.
Mhm.
So that's why like
I
they,
mean, apart from approvals apart, technically speaking,
uh
CellStrat Hub will not suffice for your team or your employer.
yes, exactly correct, right? See, for example, one of CS Hub is like um, I'm not sure if we have the auto scaling. I think we have, yes. Um, we have this lambda which basically auto scales, right, based on the requirement, based on the traffic.
Correct.
Okay, yeah, it will still suffice, I guess. Yeah, I would definitely uh, try to use that,
Mm.
but
Mm.
again, I'm not sure how much of process you have to go through.
Yeah, yeah. No, no. I'm just
Yeah,
thinking
yeah.
the organization's CellStrat Hub is going to cut it or not. But we have to see. Yeah. I mean, CellStrat Hub, we are not taking into an MLOps direction per se. We are
Okay.
into enterprise solutioning, right? So
Yeah,
that's where we are taking it, not into MLOps, because there are robust MLOps like SageMaker. So why to go
yeah,
into that segment of business model?
yeah. But I think they will not come to CS Hub platform, but they might be interested in taking your SDK, CS Hub SDK, which basically automates lot of other process, right?
Hmm. Hmm.
Let's say if you can sell the SDK, which is the
Hmm.
Hub SDK, that
Hmm.
like the enterprise has the model, but
Hmm.
now with Hub SDK, CS Hub SDK, with just like one command, they can deploy the model and it
Hmm.
to API gateway, right? But it will be still in their AWS platform. They will not be liking to come to CS AWS.
Right, right.
Yeah.
So my final question, Bismillah, for as a recommendation strategy for CellStrat, do you think we are doing the right thing by taking CellStrat Hub into enterprise directions and not into an MLOps competitive environment? Or should we build MLOps features in CS Hub and start competing with SageMaker kind of ecosystem?
Yeah, I think the MLOps market is quite competitive, and there are other probably competitors.
There are too many actually.
Yeah,
There are
yeah.
too many.
So,
Yeah,
so I think probably an enterprise roadmap is a good bet, I think. Yeah.
yeah. Thanks.
So one comment on this, Vishal,
Yeah.
Vivek,
Mhm.
is basically there are two approaches that are happening in the MLOps, category. There are two strategies companies follow. One is in terms of locking yourself in terms of some of this um, proprietary software. For example, AWS has this MLOps, SageMaker part of theirs. Azure has their own, machine learning services, Azure machine learning services. So does Google has their machine learning services. So
Right.
that comes with that. And apart from that, if you look at, there are open source version of MLOps services which are there, and like Airflow, and you have many other services which are focused on open source version of solutions. You could look at using the open source solutions integrated part of your solution, so that you do not need to spend time in terms of building these things ground up. And because these things evolve outside, and you basically support that part of the CellStrat platform, these open source solutions. So that is another strategy that you can look at, incorporating part of CS Hub.
Fair. Thanks, Prasanna. Thanks for that thought. So yeah, I mean that sounds right. So, but as we were discussing, we probably are not looking at taking CSR into MLOps competitive environment. Rather, there is plenty of enterprise opportunity with vertical solutions for various industries, right? And with the new, generative AI, new algos, there is plenty of new business opportunity opening with various enterprise domains. So that's where I think we are going. And we are not. We did start with a AI ops vision, but I think we have now digressed into an enterprise focus area once we found brutal competition in MLOps space. And these big stacks, they are very well funded. So I mean, there's too much competition in MLOps. So whereas the enterprise is a very greenfield opportunity, so I think we are going more into vertical solutions.
Agree, Vivek.
So good discussion. I like your thoughts and recommendations. So any other comments, anybody? Okay, so amazing presentation, Bismillah. Thanks a lot, and look forward to your future sessions as well.
Yeah. Thank you, Vic, and thank you everyone for your attention.